Welcome to a quick lesson about linearization, and specifically we're going to talk about what to do when you already have an equation. We can figure out what to do with that equation in order to be able to produce a linear data set, and then what to do with that graph, what it's going to tell you. So we have an example here for velocity equals root 2k over m. And so if we were trying to compare our variables of v and k, how are we going to approach this so that we can get a straight line graph, and then two, what are we going to get off of that graph? And the secret sauce here is use the equation template. We are going to rewrite our equation into the equation template, and here's the big thing: you're not actually going to change the equation. All we're doing is just rewriting the equation within the brackets in a way that emphasizes to us the things that we need to do. So if I have a variable that's already alone, that's the one I'm going to put in my y variable spot. My x variable is going to be a little different though, and I'm going to sort out the x variable, and then everything that's left goes in constants. So what is my other variable? It's k. And so I could put my k in here, but that does not actually match the equation. And so the questions we ask ourselves when I have an equation: is my variable on top or on bottom? And is it plain or is it fancy? So this k, I think we can agree, is in the numerator. So, all right, that's good. Is it plain or is it fancy? And this k in this equation is square rooted. So I need to copy that into my equation template. So we had k in the numerator and square rooted, so in my equation template, I'm copying square root k. Now I need to finish copying the rest of the equation, and the rest of the equation has root 2 and m on the bottom. So copying in square root of 2 over m. And you'll know that you've done this correctly if you were able to take away these parentheses, and it should go back to the original. If I take away these parentheses and combine this, it should go back to root 2 root k over root m. That actually matches the original equation. So, okay, we have rewritten this equation into an equation template without actually changing it. And the equation template tells me everything I need to know, because if I've done this right, then I should be able to copy over from the y variable, put that on my y-axis, x variable spot, put that on my x-axis. And if we've done this correctly, and we've done some exercises where we've seen this, then we should get a straight line when we graph it. And why is that important? Why do we care about having those straight lines? Well, because we want to get a slope. Slopes are useful measurements for us, and the slope here is going to equal exactly what you get in the constant spot. So in the equation template, we had under the constants root 2 over m. This means that if I graph my v numbers versus square roots of k, I would take all my k values and square root them. And if I were to graph that, then my slope should equal root 2 over m. Okay, let's change this around a little bit to see if we've got a handle on it. Same equation, but we're going to say, what if it was for v versus m? So again, the original equation was v equals square root of 2k over m, and we want to compare our variables of v versus m now. Okay, well, fill in the equation template. In my y variable spot, the one that's already alone, v. In my x variable spot, m is my variable, But is this m in the numerator or the denominator? Ooh, it's in the denominator. So I need to copy that over. So if it's in the denominator, I make it 1 divided by m. Is it plain or fancy? Well, it's not just plain old m on the bottom. It's a square rooted m. In our original equation, our m is in the denominator and it's square rooted. So when I rewrite into my equation template, I copy it like that. What else is left in the equation? Well, we still have root 2 and root k on top. So in my constants spot, we're copying those over. And when we do this, when we say for one variable versus another, we're assuming that everything else here is constant. Okay, so what would you graph? This means that I would put, on my y-axis, I'd put numbers for v, and on my x-axis, I'd calculate values for 1 over root m. That should get me a straight line. And when I get that straight line, the slope of that straight line, if we've got the right equation here, that slope should equal root 2k. This is the basic idea. I'm going to show you another equation, but we're going to repeat that same idea. So we'll look at a new equation. If we've got, this is for density for a cylinder, that density would equal mass divided by pi r squared times the length of the cylinder. So let's say I am doing for variable d versus variable L. All right, let's fill in the motion equation. Fill in the equation template. In the y spot, we already had d was alone, so d equals. And what's my other variable? It's L. Is L on top or on bottom? It's on bottom, so I'm putting 1 over L. Is it plain or is it fancy? Well, on the bottom here, it's just plain L. So 1 over L, just plain, that will give me what I need, because all we're doing is copying the equation. We're not changing anything. I know I've said that a couple times, but it's worth repeating. Everything that's left goes in our constants spot. And what we should get then is, if we put d on the y-axis and 1 over L on the x-axis, calculate those numbers for 1 over L, that should get us a straight line. And the slope of that line, well, what's in our constant spot? That slope should equal m over pi r squared. Okay, let's take this from just slightly different. Let's say d versus r. If we did d versus r, so our equation was d equals m over pi r squared L. In my equation template, d in the y spot, r, well, we have r in the denominator, so okay. And is this just plain r? Nope, it's r squared. So I'm copying it as is. So all we're doing here is we're separating out this variable so that it's super obvious what to graph, and then we copy over all the rest of the equation. And again, if I take away the parentheses, it'll go back to our original, if we just recombine it back together. And so this is telling me that if I wanted a straight line, that I should graph d versus 1 over r squared, and that the slope of this line would equal m over pi L. So this is one of the main reasons we love our equation template, because if we just put our equation into it, the template will tell us what to do. All right, thank you for watching, and we'll see you in class.